So in this unit we've looked at two major ways to build the equation of a line given information about the line. The first way is if we know the slope and the y-intercept of a line, we can use the equation y equals mx plus b to build our equation, where m is the slope and b is the y-intercept. So for example, in this question here, I have a graph, a line, whose y-intercept is -2, and whose slope, if I go from this point to this point, rise to run 3, whose slope is 2/3. Therefore, by the slope-intercept form of a line, I know that the equation of a line, the connection between x and y, is y equals mx plus b. The other major way to calculate the equation of a line is point slope, and I use this if I have a point on the graph, any point, and the slope. So if I look at this graph, and again I'm going to calculate the slope just by counting. I'll move from this point to this point. I have to go down 2, so my slope, my rise is -2, and my run is 6, so my slope is -1/3. I also know that the graph passes through the point -4, 2, and so since I know a slope and a point, I can use the point slope form of the line, which is basically just the slope formula rearranged, to calculate the equation of a line. So remember that x1 and y1 are the specific point that I know, x1, comma, y1, and so I'm just going to substitute into here y minus 2 equals -1/3 x minus -4. So now I'd like to introduce a third form of a line called the general form of a line, which is of the form ax plus by plus c equals 0, where a, b, and c are constants. They're integers, with the first integer a being positive. Now the general form is not quite as useful as the slope-intercept and point-slope forms, but the general form is often the way that we give our final answer. It's kind of like the standard way of presenting the equation of a line. So if I take my answer from the two questions I just did, the first answer from the question I did previously, I have my answer in slope-intercept form, y equals mx plus b. What I'm often going to be asked to do is to give this equation in standard form. So what that basically means is that I want my equation set to 0, I want the x term, then the y term, then the constant equaling 0, and I want to ensure that a, b, and c are integers, which means no fractions. So what I'm going to do here is I'm going to rearrange this equation into a different form, into general form. And to begin with, because I'm not allowed to have fractions in standard form, in general form, we often call these interchangeably general or standard form, I'm going to clear the fractions by multiplying both sides of the equation by 3. So if I multiply both sides of the equation by 3, I'm going to get 3y equals 2x minus 6. And to get general form, I'm going to set my equation to 0. ax, bring the y term over, plus by plus c equals 0. Okay, and we've got general form. A is 2, b is -3, c is -6. Now as I said, general form is not as useful as slope-intercept form, because even though these two equations are the same, the advantage of this is that I can see the slope and the y-intercept. With general form I can't. But as I said, it's just a more general way to present the equation of a line. Alright, let's look at one more example. So I'm going to take the answer from the second example I did previously, and I'm going to rearrange this answer into general form. So my answer, remember, was given in point-slope form. I could see the point and I can see the slope, but I'm going to rearrange it into general form. So again, I'm going to start off here by clearing the fractions. So I'm going to multiply both sides of this by 3. So if I distribute, I get 3y minus 6 equals, here the 3 cancels out and the negative gets distributed in, negative x minus 4. And I'm going to set this to 0 because that's what general form is, ax plus by plus c equaling 0. So I'm going to have negative x minus 3y, add 6 plus 2. Alright, now I'm just about finished, but the one little condition about general form was that the leading coefficient had to be a positive integer, and here it's a negative integer. So I can solve that issue by multiplying both sides of this equation by negative 1. And 0 times negative 1 is still 0. Distributing my negative 1 through, I get x plus 3y minus 2 equals 0. The general form, ax, a is 1, plus by, b is 3, plus c, c is negative 2, equals 0. Now you might wonder if general form is not as convenient as slope-intercept or point-slope form, what's the purpose of it? Well, first of all, it does kind of make the equation look a lot simpler. Your equation won't have fractions in it. It'll all be set to 0. It'll look very neat. The other useful thing about general form is that it's very convenient for calculating intercepts. Here's a linear equation. It's a first-degree equation, and it's given to us in general form. Now, if I ask you to calculate the x-intercepts, which occurs when y is 0, if I substitute 0 in for y, the work is usually pretty quick to do. 4x is 20, so x-intercept is 5. Then to get the y-intercept, if I make x 0, do my substitution, 4 times 0 minus 5y minus 20 is 0. I get negative 5y is 20, so the y-intercept is negative 4. And then I can quickly sketch my graph, an x-intercept of 5, a y-intercept of negative 4. I know it's a line, so I get my sketch. So when an equation is given in general form, it's usually quick to find the x and y intercepts, usually more so than any of the other two forms. Alright, let's put all of this together by looking at this final example. We want to find the equation of a line in general form that has an x-intercept of negative 2 and is perpendicular to this given line. So there's a lot of stuff going on here. I'm going to do a little bit of a picture in terms of what we know. We are looking for a line that has an x-intercept of negative 2. So that line passes through this point. And the line is also perpendicular to this line. Alright, so it would be helpful, I think, to know what this line looks like. And so I'm going to do a little sketch of this, and there's a number of ways I could sketch this. I could calculate its x and y intercepts. I could also arrange the equation in the form y equals mx plus b. And that would allow me to know the slope and the y-intercept, which might be handy for another part of the question. So I'm going to isolate y here. So I'm going to move the 3x and the 12 to the other side. Divide by 4. And so the equation has a slope of negative 3/4 and a y-intercept of negative 3. So if I just plot this, y-intercept of negative 3 is there. And a slope of 3/4 would mean that if I dropped 3 units and ran 4, I'd have another point on the line. So the line I'm trying to find passes through this point and is perpendicular. So roughly speaking, it looks something like that. It's a 90-degree angle there. Now, the question here is asking us to find the equation of a line in general form. Now, just because we're being asked to calculate the equation in general form doesn't mean that we're going to begin with general form. What we'll typically begin with is one of the two building blocks that I started this video with, either the point slope form or the slope-intercept form, and it will all depend upon what we know about the line we're trying to calculate. The red line, we know a point that the line passes through. We also know the slope of this red line because since it's perpendicular to the green line, the green line's slope is -3/4. Therefore, the line in red is the negative reciprocal of this, which is 4/3. And these are our two building blocks for our equation. In this case, a point and a slope. So I'm going to use the point slope form of a line to build the equation. Y minus 0 equals 4/3 x minus -2. Alright, now that I have my equation built, I'm going to finish it off by putting it in the form that I've been asked to put it in, general form, just by rearranging the equation. So I'm going to take my equation, I'm going to multiply both sides by 3 to clear the fractions. Okay, and so that's 3y equals, the 3's cancel here. We distribute the 4 through. Set our equation to 0, ensuring that our leading coefficient on x is positive. 4x minus 3y plus 8 equals 0. I have the equation of the red line in general form. And if I want to do just a little test just to ensure that it's probably right, I do know that it passes through -2, 0. So if I substitute in for x and y into the equation should be satisfied. 4 times -2 is -8, minus 3 times 0 is 0, -8 plus 0 plus 8 indeed is 0. So I'm fairly confident that my answer is correct. So just to conclude, notice that when you're asked to calculate the equation of a line, you'll usually use point slope or slope-intercept form to build the equation, and from there move it into general form.